Welcome to the course of distributed system. In the previous session, we discussed about the distributed shared memory. Today, we are going to discuss algorithms for implementing distributed shared memory. We discussed the basics of the distributed system, distributed shared memory. That is, distributed shared memory is a resource management component of distributed operating system that implement shared memory model in the distributed system which have no physical shared memory. That is, we are going to implement the shared memory concept in the distributed system. Then it becomes the distributed shared memory. Traditionally, we are using the message passing as the inter-process communication. In the case of distributed shared memory, we are using shared memory concept in distributed system. Then it becomes the distributed shared memory. There is no physically shared memory. These memory are virtual in nature. That is, we are taking some part of the block of the each and every node as a shared memory regions. Today we are going to discuss some of the algorithms to implement the distributed shared memory. That is, there are mainly 4 algorithms used for the implementing the distributed shared memory in distributed system. First one is the central server algorithm, then second one is migration algorithm, then third one read replication algorithm, then full replication algorithm. First, we are going to discuss the first one, that is a central server algorithm. In the case of central server algorithm, there is one server, then there are some number of clients. It is like the client server model. In this algorithm, this central server maintain all the shared data. That is, all the controls are in the central server. So central server maintain all shared data. It services a read request from other nodes by returning the data item to them. Whenever a particular node needs a data, it will send a data access request to the central server. Then the central server will service that read request from other nodes, that is from requested node, by returning the data item to them. It also services, the central server also services write request by updating the data item and returning the acknowledgement message to the corresponding requested process or client. That is, it services both the request, that is read and write request. During the read request, it will return the data item to the corresponding client. During the service of the write service request, the particular the central server update the data and return the acknowledgement message to the client node. That is the situation. In this central server algorithm, the timeout can be used in the case of failed acknowledgement. There is a chance of delay or fail the acknowledgement from the central server. So it indicates that the corresponding read or request or a write request is not reached the server. So after the timeout, the client can send the request again. Also, the sequence number can be used to avoid the duplicate write request. So this is the case of the central server algorithm. Here the advantage of this algorithm is that it is simpler to implement, or the implementation is simpler, but the disadvantage or the failure of the system is that the bottleneck. There is a chance that the central server can become bottleneck. To overcome this situation, the shared data can be distributed among several servers. That is, in the central server, all the data are maintained by the central server. So it will become a bottleneck. That is, if the particular central server is failed or crashed, the entire system will be in a deadlock situation. So it can be avoided by sharing data among several servers. This distribution can be done by based on address or by using some mapping function to locate the appropriate server. So it is one of the idea. There is distributing the data among several servers based on some address. From this address to this address, one server is handling or one node is handling the particular addresses, or by using some function to locate the appropriate server. That is about the central server algorithm. Then come to the next algorithm, that is migration algorithm. In contrast to central server algorithm, in migration algorithm, every data request is forwarded to location of the data. That is here each and every data is stored in different locations in the distributed system. So if a particular request, data request or access request is coming, it is forwarded to the location of the data. In migration algorithm, this data is shifted to the location of the data access request, which allows subsequent access to the to be performed in locally. That is, when a particular request is coming, along with the data, along with that particular data is going to shift it to the location of the data access request. That is, when a particular node, here you can see that a data request is generated by the leftmost node in the system. The request going to the third, the data is available in the third location, third node. So the data request is going to the third location or third node. Then that node will transfer the entire block which contain the requested data to the data request location. Data request location means the first node. It allows only one node to access a shared data at a time, and the whole block containing the data item migrate instead of individual item requested. So it can use it is suspected to it can use the locality of reference. That means it may be there is a chance that it access the data within that block again and again. So it use that locality of reference properties. Then it is susceptible to trashing, where page frequently migrated between the nodes while servicing only a few requests. That means if we transfer one of the block V1 to that corresponding requested process, it may contains only one line required by that particular process. Then again a particular request is generated which does not contains within that particular block. Again we have to perform the paging. So it will go into trashing situation. That is, requested page is not available locally on the system, so it will become trashing. That is one of the problem in the case of migration algorithm. Then this algorithm provides an opportunity to integrate the distributed shared memory with the virtual memory provided by the operating system at the individual nodes. In addition to the distributed distributed shared memory, we can use the virtual memory provided by individual nodes in the distributed system. That is one advantage of this system. There is a chance of trashing. There is a disadvantage or the problem with associated with this algorithm, but we can use the virtual memory associated with the individual nodes. Also, we solve the problem of central server algorithm, that is bottleneck at the server, central server. Okay, that is about the second algorithm, that is migration algorithm. Then come to the third algorithm, that is replication algorithm. Read replication algorithm is an extension of the migration algorithm by replicating data blocks and allowing multiple nodes to have read access or node to have both read or write access. That is the situation here. In the case of it is some extension, that is this block is transferred, means it is replicated. Only one copy is the system maintain more than one copy of the same block. That is called a replication. So the read in the read replication algorithm, the replicated data it replicate the data block and allow multiple nodes to have read access or one node to have both read or write access. It is the system contains more than one copies of the same block, that is called replication. Then it allow multiple nodes to have read access. So there is no problem if we allow more than one nodes to read the same data, there is no problem. So it will increase the performance of the system. More than one process can access the or read the same data at the same time. Or we can restrict it that it can read and write by only one node. If we allow the read operation, then it must be consistent. So only one process is allowed to read and write. But in the case of read, only read, we can allow more number of processes. Multiple nodes can be allowed. That is the case of. So it improves the system performance by allowing multiple nodes to access the data concurrently. The write operation in this particular algorithm is expensive because as all the copies of the shared block at various nodes will either be we have to invalidate or update it with the current values to maintain the consistency of the shared data block. Here you can see that a particular X block is shared in more than one places. If a particular data is copied to a location of the node, then after the updation, after if any data is become invalidated or updated, it must be reflected in all the blocks in the all the replicas. Replica means copies. Replicas in the system. That is on that is we have to. So the write operation is expensive. Here you can see that the write operation in read replication algorithm, that first node requests access to the third node, then that you transfer the the entire block to the first node. Then if it performs some write operation, the data may be updated or the data may be invalidated. So that situation, these update or invalidated data must be updated in all the copies or all the replicas in the system. So the write operation in this algorithm is expensive. That is about the write operation. So the distributed shared memory must keep track of the location of all the copies of the data block in the system. Then only we can update or invalidate the data. Then next algorithm is fully replication algorithm. It is an extension of the read replication algorithm. In a read replication algorithm, we only allow multiple read or only one read and write operation. That means we will allow multiple nodes to perform the read operation in the same data, or we will allow only one node to perform a read and write operation. In the case of fully replication algorithm, which allow multiple nodes to have both read and write access to the shared data block. We are allowing all the nodes or more than one blocks to perform the read and write access. Since many nodes can write shared data concurrently, the access to the shared data must be controlled to maintain its consistency. So in the previous case, that is read replication algorithm, we only allow write access to only one node. In the case of replication algorithm, we allow more than one, that is multiple nodes to perform the write operation. So we have to maintain we have to control the consistency in the data block. To maintain the consistency, it can use a gap-free sequencer. Here in the system, we are using a sequencer that is called a gap-free sequencer, in which all the node wishing to modify the shared data will send the modification to the sequencer, which will then assign a sequence number and multicast the modification with some sequence number to all nodes that have a copy of shared data. That is about this algorithm. That is, when a particular node want to perform the update operation, then it will send the request to the sequencer, gap-free sequencer. The gap-free sequencer will collect all the requests. After some times, it will assign some sequence number, and it will send it will multicast the updates to that corresponding nodes which have the copies of the data block. Then based on that particular sequence number, it can perform the operation. It can perform the update operation. That is about the sequencer and the write operation in full replication algorithm. Okay, thank you.